Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Mashoud Mamburu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Today we'll be revising. Our revision will be on physics, physical sciences, paper 1, which you are writing tomorrow. We're hoping that you will get marks and you will be able to move and you will have understanding. So the main aim of this lesson is to ensure that you are ready for paper 1. You are going to collect marks. You are going to be able to answer all the questions that are going to be asked on the paper. And if you check the topics for paper 1, as we usually always say, you have written prelim. Now you know the structure of the paper. To say we have 65 marks that comes from mechanics. We have 15 marks, which is your wave, sound, and light. That is your Doppler effect. You have 55 marks that comes from electricity and magnetism. You'll remember you are having your electrostatics, you are having your current electricity, you are having your electrodynamics. Now, you have your 15 marks for metal material, which is your last question, which is your photoelectric effect. So those are the questions that you do. It would be nice that these questions with 15 marks, you are able at least to collect that 30 marks, because that will be a good thing to do. Remember, 30 out of 150, that will be about 20% of the paper. So it's important that sections like wave, sound, and light, which are easy to collect marks, you collect as many marks as possible. Questions like photoelectric effect, you collect as many marks as possible. However, for this lesson, we're going to go through all these topics. So we're going to move. And then we are saying the total is 150 marks. You'll be sitting for 3 hours. And we are saying the weighting level 1 questions is 15 marks. You have your comprehension, your understanding, and then you have your analysis with 40, and your evaluation questions, which is 10% of the paper. So that is what you are expecting when you write your paper 1. It's still 10 multiple choice questions, which is 20 marks. And you are saying structured questions, you'll get 110. 80 marks. The total is 150 for 3 hours, as I indicated. Now, if we look at the structure of multiple choice questions that were written last year in November 2023, we had question 1, which is 10 questions, 2 marks each. And we are saying on the multiple choice questions, answer all the questions. Don't leave any question unanswered. And if you look at the structure, we had Newton's laws of motion in 1.1 and 1.2. We had VPM, or vertical projectile motion, in multiple choice question 1.3. We had momentum 1.4. We had work, energy, and power 1.5. We had Doppler effect in 1.6, 1.7. We had electrostatics, and then 1.8 we had the electric circuits, and then 1.9 we have electrodynamics, and 1.10 we had photoelectric effect. It's important when you're answering multiple choice questions to know which section or which topic the question is coming from, because when you answer, you'll be able to respond correctly. Now, we are saying the structure of today's lesson is in this way. We'll look at the content for the whole topic. We'll summarize it and move forward. Remember, the main thing here, problem-solving strategies. How do you go about answering questions? We can't leave definitions out. Remember, we are saying for all the questions that you are going to write, you are going to find questions that says define. So we are saying if there are 9 definitions, questions, please get all the 18 marks, and then you know that you are able to move. So this is the first mark that you ensure that as far as definitions are concerned, you're going to collect your marks. And we are saying problem solving in terms of your multiple choice questions and structured questions. And then the topics, as indicated, we're studying with Newton's laws of motion. Remember, we're doing the Newton's first law, second law, third law, and Newton's law for universal gravitation, vertical projectile motion, momentum, work, energy, and power, Doppler effect, electrostatics, electricity, electrodynamics, and photoelectric effect. So that is how the topics are arranged for this particular lesson. I'm hoping that you have a pen and paper and a calculator. You'll be able to do that. You have your data sheet close to you. Remember, a data sheet is something that you will always keep close to you, so that you are able at all times, you are able to go to the data sheet and be able to choose the correct formula. Remember, if you choose the correct formula, you must be able to substitute on that particular formula. If you just copy the formula from the data sheet without substituting on it, you won't get that 1 mark of the formula. Please ensure that you trace your formula. Now, in terms of Newton's first law, we are saying there are 3 things there that we must think of. Is that the object is at rest. An object will remain at rest, not moving. And then we are saying, or the object is moving at constant velocity, or we are saying the forces are balanced. When the forces are balanced, we know that the object won't be moving. So hence we say Newton's first law is F net equals to 0. So when you're stating it, you will say it to say, okay, an object will remain at rest. That's why F net is 0. An object will remain at rest or in constant velocity. Constant velocity simply means final velocity is equals to initial velocity. So if we look at the acceleration there, it will be 0 because Vf equals to Vi. So that is constant velocity, meaning the velocity is not changing, or when the forces are balanced. So you got to know Newton's first law. We're saying an object will remain at rest or in constant velocity unless acted upon by an external resultant force. Now, Newton's second law, we are saying now F net is no longer equals to 0, is F net equals to MA. It's there in the data sheet. So if you have forgotten, just go there. Then the main thing here, you are saying when the net force is applied on the object, remember the object has mass M. When a net force is applied on the object will accelerate in the direction of the net force. So that's what we are saying. We're saying when a net force is applied on the object will accelerate in the direction of the net force. However, you get your marks when you start to say acceleration is directly proportional to the net force and acceleration is inversely proportional to the mass. You write that in weights and you are able to get your 2 marks. Please ensure that all the questions that say state Newton's laws, you are able to collect those marks. Now, Newton's third law, we are saying when body A exerts a force on body B will exert an equal but opposite force on body A. So you are able to do that as well and get your 2 marks. And then we are saying these Newton's laws, you will always remember them. Now, in terms of the problem solving strategy, how do you go about solving problems that involves Newton's laws 1, 2, and 3? We are saying in application of Newton's laws, the following are important. The main thing there, free body diagram or force diagram. I think by now you know the difference between free body diagram and force diagram. For free body, we usually just make a dot and we are able to draw our forces. However, we make a box there when we are drawing our force diagram and we are able to indicate all those forces. So it's very much important. The next thing which is very much important is this surface, whether the surface is rough or smooth, because immediately when we say rough surface, we are saying we have friction. And then when we say the surface is smooth, we are saying frictionless. There is no friction. And we are saying pay careful attention to the mark allocation. For questions involving calculations, just routine calculations, you just have to identify the formula, you substitute, and you get the answer, and that is your 3 marks. Hence, we've always been emphasizing that here in paper 1 more especially, we talk to formula, substitution, you get your answer with correct SI unit and direction. If it's a vector, we don't want you to lose marks by not indicating the direction. As long as you're dealing with vectors, you will definitely have to indicate in which direction. But when you're dealing with scalar quantity, it has only magnitude but no direction, so you don't have to show the direction. In fact, in terms of the marks, we're saying when you have 4 marks or more, you'll find that this might be a multi-step type of question. So those are things that you must always remember when you're dealing with questions like this one. Now, let's move now straight to the questions. As I indicated, the main thing here, we're going to do the strategy as to how are you going to respond to question. Last year, 1.1 November 2023, a question was asked, a constant net force is applied to a block. Which one of the following statement is correct? It's very much important before you answer a question to ask your question yourself which law, because I'm dealing with Newton's here, which law talks about a constant net force. When a net force is applied on the object, what will the object do? Because it's applied to on an object. So you're able to see that here we're saying, okay, when a net force is applied to the object must be able to accelerate in the direction of the the net force. Now, which one of the following statement is correct? The block will move with a constant velocity, constant acceleration, constantly increasing acceleration, and constant decreasing acceleration. Then you are able to see that we said, remember we said acceleration is directly proportional to the net force. So we have constant net force, we have constant acceleration. Then you are able to choose your answer there as B. Now, for 1.2, we are saying a crate of mass M is stationary. Remember, the main thing when you see an object like that in an incline is to first see the forces that are acting on that particular object. You got to understand that we always have a force that is straight here, which is your Fg. But because this Fg is certain angle, we are going to resolve it into components. Remember, when you're drawing the free body of force diagram, you don't have to resolve your forces. So your responsibility is to make a dot and indicate that, okay, there must be this Fg, because it's at an angle, we are saying that it must be having two components, which is the Fg perpendicular, which is moving in that direction, and the Fg parallel there. So you are able to see that, okay, we're having Fg parallel, that is pulling the object downwards, and then because the object is stationary, it means there must be another force that is opposing the movement of this object, and that will be your frictional force, which is now opposing the movement of that particular object. Hence, it's remaining stationary, which means we have balanced forces. So you're able to see that we have balanced forces. And which one of the following statements regarding the magnitude of the frictional force acting on the crate is correct? The magnitude of the frictional force acting on the crate is equal to the component of weight to the crate, which is parallel to the plane, or is larger than the component of weight which is parallel to the plane. So the main thing that we know that the forces that we're talking about are the forces that are parallel, because these are the two that are opposing forces that are when we look at how the object is supposed to move. Now you can be able to see that it's not the perpendicular forces that makes the object moves in this direction. So it must be A or B. But now for the object not to move, it means the two components, the Fg parallel and the friction, they are equal. So you are able to see that the correct answer must be saying it is equal to the component of the weight of the crate, which is parallel to the plane. So you are able to do that with no problem, and then you are able to choose your correct answer. Now, we are given now a scenario there to say a 5 kg block resting on a rough horizontal plane. Please ensure that you are showing, you are highlighting that rough, because now you are saying this is a rough surface. It tells you that we have friction. So don't forget that it's connected to a 12 block by a light inextensible string that passes over a light frictionless pulley. A 5 Newton force. So we're having a 5 Newton force, which is our applied force there, to the 5 kg block at 80 degrees to the horizontal as shown in the diagram below. I think now already you start to remember that the question can be a state Newton second law, and then or the question can be draw free body diagram. In this case, the question said draw free body diagram showing all the forces acting on the 5 kg. Please underline that 5 kg. You don't want to make a mistake of drawing forces acting on the 12 kg block while the question is talking about the 5 kg block. So it's important that always you know that which block are you talking about. Now, on the 5 kg, please don't resolve no forces. What you do, you will draw, it's a free body, so it's a no body diagram. You just make that dot, draw the forces as they appear on the object there, to say, okay, we are having our tension that is moving there to the right, and we are having now our applied force of 5 Newton that is going upward like that. That is our applied force. We are having our normal force that is always perpendicular to the surface, and we are having Fg that is always going down. But remember, they said that this is a rough surface, so don't forget that they said that this is a rough surface, so we must be having friction that is opposing motion like that when the object is moving. So you are able to know now how your object are going to your free body diagram is going to look like, and how you're going to get your 5 marks. And the next question was the coefficient of kinetic friction between the 5 kg block and the surface is 0,2. Immediately when you see that 0,2, you will know that when do we use the coefficient of kinetic friction. You know that that is when we calculate our normal force. So when we calculate our normal force, we can be able to do that. Hence, we have the question that says calculate the normal force acting on the 5 kg block. Now, here is very much important for you now to think about how we are going to resolve our forces. Remember, we have a force at an angle there. That's why it's not the same. When the force is at, for example, when you are having an object in a horizontal plane, your normal force will just be straightforward. You'll just be the same as mg. But in this case, your normal force is not equal to weight because you are having another component that is acting upward as well, which means now your weight is equal to the normal force plus the component, which is the vertical component, that is equals to weight. So you are able to know that now, because we are at an angle, our normal force will include the component now, which is our Fy, which is our F sine theta, which will be our F sine 30, because our theta is given as 30 there. So it's very much important that you have that, and then you are able to say, okay, normal force would be the difference between mg. Remember, our weight is mg, so it will be mg minus 5, which is our force, sine 30. And then we are able to go to the calculation without wasting time to say you will have the component, the normal force plus the component equals to weight, and we are saying this is 30 degrees. So you are able now to calculate to say, okay, if we say our 5 and that 9,8, we are able to get our normal force of 46,5 newtons. And the next question was the question on calculate the kinetic friction. For kinetic friction, we are saying don't forget this formula is in your data sheet. You will get that 1 mark for the formula. You will get the 1 mark for substituting the coefficient of kinetic friction, and 1 mark for and the last mark for getting the correct answer with the correct SI unit. Then you are able now to say we are getting our 3 marks here for calculating the kinetic friction. I hope that helps you. When you go to our last question, which is 2.4, which says calculate acceleration of the 5 kg block. It's very much important here. That's when we're saying apply Newton's second law, because Newton's second law, we are saying F net equals to ma. So when we're saying F net equals to ma, what are we saying here? We are saying, okay, add all the forces that are acting there. They must be equal to ma. And if we check when we were drawing our force diagram, we're able to say, okay, how many forces that we are having there in terms of the 5 kg block. So you are able to see that, okay, we are having 5 Newton that is being applied. We are having the frictional force. We are having the tension. The main thing there is the sign to say the direction where the tension is going and the direction where the friction and our Fx, our horizontal component in terms of this force are going. They are in opposite direction. You will see as we do the solution, we are going to say F net equals to ma, but we are saying the friction and Fa and our applied force, the component of the applied force, are in opposite direction. Hence, when you add the forces to get F net, you will say T plus, you indicate that the friction is in the opposite direction and the horizontal component is in the opposite direction. Hence, you write them as negative, and you are able to substitute them. You'll get your 5a when you take your friction that side, which was 9,3, and your 5 cos 30, which is your fax. You're able to get that, and then that is your equation number 1. So that becomes your equation number 1. We're bringing back maths here. Remember, you have been dealing with simultaneous equation. Remember, you have two unknowns here. You have t and 5a. So you can't solve that problem because you have two unknowns. So you must go to body number 2, which is the 12 kg block. In the 12 kg block, you have seen it was hanging like that, the 12 kg block, which means we had our tension, which was in the opposite direction, and we have our weight, which was going downwards. So it's important that even if we didn't ask you to draw the free body diagram for the other object, you are able to draw it because you will be able to determine the two forces. So you can see that our F net now for this one. So you are applying F net equals to ma on the second block, and then you are saying that will be weight positive and then t in the opposite direction, hence it's negative. But you still show that you are adding them because this is a net. Net means you are adding together. And then you are able to say the mass was 12. Then you are able to say mg minus t equals to 12a. And then you are able to substitute your mass, which was 12, and your g, which is 9,8. And then you make t subject of the formula. Because all of them, they are equal to 2, it means 1 is equal to 2. So you can equate this equation to that equation. And after that, only maths is done. It's left, the science is finished. All you have to do now is to apply your maths. You put this part on the left, the other part on the right. And then you are able now to have one unknown, which is a. And then when you take the 12a, that side becomes 17. 17a becomes positive. Then you divide by 17 both sides. Then you are able to get your answer of 6,12 meters per second squared. I'm hoping here that you will ensure that you don't do the body system thing. You just apply Newton's second law for body A and apply Newton's second law for body B separately. Then you get your two equations. You now simultaneously solve your equation until you find our acceleration, which is what we did on this question. Without any wasting of time, we'll be moving to the next section, which is your vertical projectile motion. As I indicated, here we are showing you how to collect the marks. So for question 2, we're saying the free body diagram. You have your marks there. For writing F net equals to MA, you had your marks. Be able to add all those forces that are acting on the object. And then we have shown you the importance of plus and minus, because the direction will tell you that the other ones are going in the opposite direction. Then you are able to subtract the ones that are opposing the motion of an object. Now, under vertical projectile motion, here we have two important definitions that you must know. It's a definition of a projectile. So we're saying, please, when it comes to the definitions, don't lose no mark. Collect these marks. We're saying now, a projectile is an object which has been given an initial velocity. So we're not wasting time. We're saying when it's an object that has been given initial velocity, and then it moves under the influence of gravitational force only. So you can see that the second part, which is now the motion under the influence of gravitational force only, is what we refer to as free fall. So which means your projectile, the moment it leaves the thrower's hand, your projectile now undergoes free fall. So you are able to see that these definitions, they are almost the same, but the difference is that for a projectile, it must first be given an initial velocity. So we're saying a projectile is an object which has been given an initial velocity, and then it moves under the influence of gravitational force only. Now, what is free fall? It is just motion. It's a motion during which the only force acting on an object is the gravitational force. So you can see that we are saying this last part of projectile is what we are saying when it comes to a free fall. So please, we are saying these are the two most important definitions for this section. Know them and be able to collect your marks. Now, you must know how to use the equations of motion to determine the position, the velocity, and displacement of a projectile. You must know how to sketch the velocity versus time graph. We're saying, please, any question that says sketch a graph, position versus time graph, velocity versus time graph, acceleration versus time, please, you can't leave exam without responding to a question that says draw these types of graph. You will have seen that when you're dealing with your position versus time graph, you will definitely just draw what is happening. If a ball is thrown up, then it comes back to the thrower's hand, you just draw it like that. Then if it passes, then you draw that it passes like that, and you are able to show that here with time in seconds. So that's when we're saying upward is positive. So you are able to draw whatever is happening, you just draw as it happens, and that gives you a position versus time graph. However, when it comes to velocity time graph, we're now dealing with our straight lines, which are not horizontal. So we're saying, okay, it has initial velocity, okay, it reaches maximum height, and then it goes and passes. So if it passes, you can see that the motion when the object was going down, it took longer. Hence, your line won't be the same, because if it passes the thrower's hand, you'll have a longer line after maximum height. And you are able to say, this is my velocity in meters per second versus time graph. Please be able to collect those marks. The same with your acceleration versus time graph, which will be a positive like that. And then if you were changing the direction, then it's able to move like that. And you are able to label your axis to say acceleration is in meters per second squared and time is in seconds. Please collect those marks of drawing the graphs. The main thing is to dress these graphs with the values that you will have calculated. If there is time to reach the maximum height, time to do it, you are able to now substitute those values there, and then you are able to get your marks in terms of the graphs. Please don't lose marks pertaining to that. The objects, free falling object, the issue of an object thrown vertical upwards, an object thrown vertical downwards, and bouncing balls, the bouncing objects. So we only do the bouncing balls, and then we are saying if you for a given graph, you must be able to determine the position, displacement, and velocity or acceleration. So we'll give some of the questions. Tomorrow you are expecting either you will get a graph or you will get information. Then you will be asked either to draw a graph if the question comes, or you will be given a graph, then you will answer questions based on that. So please, those two scenarios is the things that as you are preparing now for your paper, you ensure that I am able to answer questions if I'm given information, and then I'm able to read and do data collection and choose the formula and do calculation and draw the graph. Or I will be given a graph, then I will utilize that graph information in order for me to answer the question. I think you get that, and you will be able to do that. Now, we are saying now vertical projectile motion, as we indicated, the two definitions very much important. What is a projectile? What is free fall? Those ones, they must be in your pocket. As if they are there in the paper, you are able to get that. But I want to emphasize here the importance of the data sheet. This data sheet is your friend. You must move with it. But data sheet is nothing without data collection. We are saying collect information, and the information that you have collected is the one that will tell you which formula will be able to help you to answer the question. Please ensure that you don't choose the formula. You don't have favorites here to say, this is my favorite formula, I will always use it. No, you collect data, and data will tell you which formula you're going to utilize to answer the question. So those are your 4 equations of motion under vertical projectile motion that you will be expected to do. Now, we always say on the strategy of VPM to say draw the trajectory. It's better to draw to answer questions of something that you can see. So we are saying you draw the trajectory and you put critical points in your trajectory. What are the critical points? We are saying the point of launch. For example, at A here, you're on top of a building. So that is the point of launch. So when the object is going up, you know it has initial velocity, and at B there, it reaches maximum height. Those are small things, but we're expecting that you don't do mistake. You always draw your trajectory, and you make sure that you look for the point of launch, the maximum height, which is our B there, the point symmetrical to the point of launch, which is C. Is that point is important because we are saying there the velocity now at A is equals to the velocity at C. What is different is the direction which the object is going. And then we are saying the time it takes from A to B is the same time from B to C. So for you, if we say calculate the velocity at G, you know that that velocity will be more than initial velocity, because as we pass the point C, the velocity is now increasing until it reaches G, which is our maximum velocity just before it rests at the ground. Now, we're saying choose the sign convention. It's very much important to say upward is positive or downward is positive. We can't stop to emphasize that, because that's where learners lose marks. If now you are just putting everything as positive. Remember, when the object is going up, you got to tell us that upward is positive, then we'll know that G, which is going downward, will be negative. So it's important that you do that. And we are saying, don't forget the points of symmetry. I've talked about it. Or we talk about the time symmetry to say at C, the time is the same as A from A to B or from B to C. And then the velocity symmetry at C, the velocity is equals to the velocity at A, because now the difference is the direction. The constant magnitude and direction of G. We're saying G, or gravitational acceleration, is always downwards and is 9.8 meters per second squared. Please, if they're saying what is the magnitude and direction of acceleration, you know gravitational acceleration is 9.8 meters per second squared downwards. Always consider motion between any 2 points. Please, instead of solving the whole scenario, just let's solve issues small, A, B, B, C, C, G. Then it becomes easier for you to do that. and we are still emphasizing the FSAUT to say you will after you have collected data, because the data will tell you which formula is correct, you will write the correct formula, you will substitute on that formula, you will write the answer, and your answer must go with the what? Correct SI unit. And if you are dealing with a vector, you will talk to the issue of direction. Please, let's not lose marks on those small mistakes of not utilizing that. A stone is thrown vertically upwards and returns to the thrower's hand after a while. Which one of the following position versus time graph best represent the motion of the stone? So you are able to see that, okay, if the thrower was there, he throws the object up, it comes back to the thrower's hand. So it's supposed to have traveled same distance in terms of that one, so that it doesn't help us. But now you are able now to see that, okay, this one not necessarily looking like a position versus time graph. Remember, they are mostly our curves, and then we are having this one. You can see that the thrower is throwing from there, reaches maximum height, comes back to the thrower's hand at C. So you're able to choose C with no doubt. Now 1.4. A person dives from a high platform into a pool. At which one of the position A, B, C, or D will the magnitude of its momentum be maximum? The main thing we want to show here, remember the trajectory that that this person is undergoing. This person is diving from a high platform into a pool. So that's the motion. So you know that from D to maximum height C, velocity was decreasing. Now, when we come back to the where the person dived from, we are saying the velocity is equal. Remember, we talked about time symmetry and velocity symmetry. So you're able to see that, okay, the velocity now is equal there. At B, the velocity is increasing. At A, just before he hits the water, the velocity is maximum. And the question is about what? Momentum. And you know that momentum is defined as the product of mass of an object and velocity. So you are able to see that that question now will say P equals mv. The V is maximum, which means we have maximum momentum at A, because it depends on the velocity. So you are able to say the position where we have maximum momentum is position A, and that is number A. So you are able to get your 2 marks. Hence, I said when I started that you are not going to leave no multiple choice unanswered. We must be able to see A, B, C, D. No matter how unsure you are, you will put something there. You can't leave the space. You will put something, because you have 25% chances of getting that correct answer. So please don't leave multiple choice unanswered. Now, with no wasting of time, we look at a structured question. This one was based on the graph. As I indicated, the main aim of this is for you to have the strategy. If you have a graph like that, that's saying a ball is thrown vertically downwards, immediately when you say thrown, you know we're talking about a projectile. And we said a projectile from the top of the building and bounces a few times as it hits the ground. The velocity time graph below describes the motion of the ball from the time it's thrown to a certain time t. Take downwards as the positive direction and the ground as the zero reference. The graph is not drawn to scale. The effects of air friction are ignored. So that is very much important. Then you are able to see that, okay, it was having now, it was thrown vertically downwards. Hence, you see that it started with initial velocity of 10. As it's going down, its velocity is increasing until it reaches now 29.6. Then it bounces. When it bounces, and then it spends 0.2 seconds there on the ground, because that's the type of the questions they might ask you, or to say how long did it take for it to reach the maximum your maximum height there, which is your 2 seconds. So it's important that you have all that information and you know what happened before or after the bouncing. With no wasting of time, let's go to questions. Write down the speed with which the ball is thrown downwards. So you just there, you know that is the initial velocity. The initial velocity is the velocity at time 0, t equals to 0. So you are able to say initial velocity was, you can't say 10 when you talk about speed. You must say 10 meters per second. SI units are important, so we emphasizing to yourself, show that it's 10 meters per second. Now, all parts of the graph have the same gradient. Give a reason for this particular reason. For this particular questions. So it's very much important for you to start now to ask what will be the gradient? What will be the gradient under velocity time graph? Remember, gradient is changing y over changing time. Don't forget that. Changing y is changing velocity over changing time. So you know changing velocity over changing time, that must be acceleration. You remember we said g is constant. Gravitational acceleration is constant. It remains 9.8 meters per second. Hence, we are saying the gradient of the velocity time graph is equal to the acceleration of the object. And the acceleration is what? Is constant and equal to the acceleration due to gravity, which is our 9.8 meters per second. I hope you get that and you are able to move. And I hope we are moving together. Now, let's go to calculation type of questions. Saying calculate the height from which the ball is thrown. Calculate now the height from which the ball is thrown, because this whoever was throwing the object was on top of a particular building. Now, the importance now of this is that you must be able now to say what is the data that I'm having, the data that you can be able to collect. You can see that our initial velocity we had there was 10 meters per second. Our final velocity was 29.6. Our acceleration 9.8 meters per second squared. So all that information is very, very important, because as and when you come to this data collection, you are able to show that, okay, I had initial velocity of 10, and then the velocity there was 29.6, acceleration was 9.8, change in y is what we're looking for, and then change in time, it took 2 seconds to reach there. So you're able to collect all that information. When you choose the formula, you know that the correct formula must be having change in y, because you're looking for change in y. That makes this to be disqualified. And then you are able, when you go to the second one there, change in y via delta t, you are looking for change in y, you are having initial velocity, you are having time, you are having acceleration and time. So you are able now to use that formula and get. And you can use any other formula that will help you to solve that question, and you are able to determine the height of the building, which was 39.6, and then the time t shown on the graph as well. You are able to calculate the final time there. Remember, for t, you know already that we had time there, which was 8 seconds, and we want the time that we dealt with there. And then you are able to know that the final velocity there, because here on the graph that will be 0, and then you are able now to do your calculation. Initial velocity was minus 25, and then you know the acceleration, and then you can determine your time. And with no wasting time, you're able to determine 2.455 as your time. You add the 8 plus 2.55, because the question was the time from there to there, which is 8 plus the 2.55 for that motion. Then you are able to get 10.55. I hope you will do as many questions as you can based on the graph. To say, write down the time the ball is in contact with the first bounce. After the first bounce, there we said it's 0.2 seconds, because it's between 2 and 2.2. And then it was write down the time at which the ball reaches its maximum after the first bounce, and then we were able to say that was your 2.2 seconds. Is the collision of the ball with the ground elastic or inelastic? So that question is important, because we are saying now, is our kinetic energy remaining the same? So you can see that as the ball spends some time on the floor, you can see that there is change in velocity. So you can see that it is not elastic. Why? Because kinetic energy is not conserved. Remember, we are saying that for elastic, kinetic energy must be conserved. Now, with no wasting of time, we're able to move to our linear momentum and impulse. Now, again, we're going to emphasize the importance of definitions in terms of this one, to say our momentum is a vector, and momentum from the data sheet, P equals to mv small p. And then you know that we are saying it is the product of mass of an object and its velocity. It is the product of mass of an object and its velocity. That is the 2 marks you're expecting if they say define momentum. And we're saying momentum is a vector, which means it has got both magnitude and direction. And we're saying any object that is moving has momentum, and the symbol for momentum is small letter p. Units of measurement of momentum, remember mass is in kilograms and velocity is in meters per second. Hence, momentum is measured in kilograms meters per second. And because velocity is a vector, that's what makes momentum a vector. And we're saying momentum is P equals to mv, where P is the momentum in kilograms meters per second, m is the mass in kilograms, and v is the velocity in meters per second. Don't forget the m for the mass there is a small letter m as well. Linear momentum, we said, is a vector, and we talked to that one. Now, let's go to tips. How do you answer this type of question? Read the scenario carefully. Hence, everything that we are doing is about reading carefully and underlining the keywords and be able to do what we refer to as data collection. And we are saying, remember the velocity, the momentum, change in momentum, and the average force. They are all vectors. And if they are all vectors, we always have to talk about their direction. So if the question is saying calculate the velocity, be careful. The question can say calculate the speed, which is a scalar quantity. So when you say speed, we're saying don't show the direction. But when you say velocity, we're talking about now a vector quantity. Momentum is a vector, change in momentum is a vector, and average force is a vector. So all of those you will take into consideration the direction. And we're saying always refer to the data sheet when carrying out calculations. But I'm saying you don't go to the data sheet empty-handed. You go with data that you have collected to say which formula is going to help me in order for me to answer my question. And we are saying pay more attention to the mark allocation. A routine question, we talked about it, is an easy 3 marks question. Elasticity of collisions, we talked about that. To say the total kinetic energy before collision, when is equals the total kinetic energy after collision, we say the collision is elastic. But for inelastic, the total kinetic energy before is not equals the total kinetic energy after. So if we say define elastic collision, you are saying kinetic energy, both kinetic energy and momentum are conserved. In elastic collision, we are saying only momentum is conserved, but the kinetic energy is not conserved. Please don't make mistakes of forgetting those things. Now, not necessarily here the main aim is for you to remember how to go about doing these calculations. Now we are saying a wooden trolley of mass 2 kg moves to the left with a constant velocity of 3 meters per second. And we are saying a bullet of mass 0.03 kg is fired horizontally from the left towards the trolley. You see the diagram makes your life much easier. Always go to the diagram and be able to see what is happening. And then I think you were fortunate. You were fortunate there as well in terms of that. Then we are able to say as I drink water, then we'll be able to finish what is left. I'll just take a small break. Then we do this question. Look at it. Then we'll be able to do it as we come. Welcome back. Now, remember we're dealing with this question. We are fortunate. Remember, it's always important for you to remember the SI unit of mass is in kilograms. So in this question, we're given our bullet of a mass in kilograms. You see now, we are being fortunate there because they should have just given it maybe in grams. Then it will have been, you will have to convert it. But when it's given in mass, both of them 2.7 kg and 0.03 kg, so the SI unit is correct. Our velocity, 3 meters per second, is correct as well. So we know that we don't have to convert first. But if you are given in grams your mass, you must first be able to convert it to kilograms. If your velocity is given in kilometers per hour, for example, remember the issue of converting from kilometers per hour to meters per second. So let's be able to move between the two. And then the bullet strikes the trolley and comes to rest inside the trolley in 0.02 seconds. So we're given the time. Already when you see this, you can see F net delta T, which is your impulse. You can see that such a question can be asked because now you have 0.02. You are given the average net force exerted by the trolley on the bullet during this time is 591. So you can see that our impulse is something that you can see 591, you can see 0.02 F net delta T, then you know that is our definition of impulse, because we are defining impulse as the product of the net force and the time taken when that force is acting on the object. Now we are saying write down the magnitude and direction of the average net force that the bullet exerts on the trolley. Remember, the one that we are given here is the net force exerted by the trolley on the bullet. So it's important for you to remember which law is this. When body A exerts a force on body B will exert an equal but opposite force. On body A, you are able to see Newton's third law. So, okay, if a trolley is exerting 591 newtons, it means now the bullet will exert same 591 newtons, but in opposite direction. So what is different is the direction, that it must be in the opposite direction. And then the next question was calculate the magnitude of the velocity with which the bullet strikes the trolley. Now, as we move, we're able to say now, for us to be able to calculate the magnitude of the velocity with which the bullet strikes the trolley, the most important thing is that we got to first know what was the final velocity. What was the final velocity is important. Then we can use the F net delta T, which is our impulse, which is equal to change in momentum. And our change in momentum is, we were given there the mass as 2.7 and the initial velocity as -3. Then we're able now to find the final velocity first. If we get the final velocity, we are able now to write the principle of conservation of linear momentum. It's important now that you remember we have defined what is momentum. We said it's the mass of an object and its the product of the mass of an object and its velocity. Now we define elastic and inelastic collision. Now we are saying state the principle of conservation of linear momentum, where we are saying now the total linear momentum of an isolated system is conserved. Now you are able to write it like that. You will get a mark for writing the principle. So it's important you can write the principle and then you can write the formula, which is your M1 V1 initial plus M2 V2 initial, which is equals to, because now this is coupling, which means that M1 and M2, the bullet and the trolley, are becoming one. That's why now we say the mass of the bullet and the mass of the trolley, you add them together and they will have one velocity. Hence you would write your formula like that. And the next thing is the issue of substitution. Please, the most important thing is the positive and the negative direction, because if you can write that velocity of -3, you write it as 3, the whole question is wrong. So always check that if they are, choose the positive direction and be able to follow up in terms of that, and then you are able to calculate your initial velocity. You can use that method, or you can calculate the change in momentum of the bullet, which is called the change in momentum of the trolley. Still, those two will be able to give you the same answer, which is the initial velocity of 395,38 meters per second. Now, as we move, question 5, which is now your work, energy, and power. Remember, you started this topic in grade 10, where you were dealing with energy. You defined gravitational potential energy. You said it's the energy that an object has due to its position. So I just take it from potential, due to its position in the Earth's gravitational field. relative to the reference point. What is the isolated system? We're saying no external forces are acting on that system. And then we say this isolated system. You have defined kinetic energy. You say the energy due to the motion of an object. Due to the motion of an object, we talk to the law of conservation of energy. Remember, we're saying energy cannot be created nor be destroyed. It can only be transferred from one form to another. You have done the mechanical energy. It's very much important that you know that mechanical energy is the sum of the gravitational potential energy and the kinetic energy of an object. Please don't forget that. And then we talk to the principle now. Remember, immediately when you say principle, you know that you're going to start by saying total mechanical energy of an isolated system is conserved or remains constant. So you are able to do that, and the formula how to write this. Now, the only mistake that learners tend to make is now being unable to expand EK plus EP or U, which is equals to EK plus EP at point A, for example, and the other one at point B. You must be able to expand this, please. Be able to know that EK is half mv squared. So at that point A plus mgh, remember potential energy is mgh at that point A, which is equals to half mv squared at point B plus mgh at point B. Please, learners, be able to expand like that. Then you can substitute and you will see that formula would work wonders if you are dealing with a question that involves that particular equation. And we're saying, apart from grade 10 knowledge, we're saying the following definitions and concepts are very much important. So you can't go wake up and say, I'm going to write without knowing this definition. So please ensure we are reminding you of all this important definition to say, you know, you must be able to know work, the work that is done by a force. And you must know that this work can be positive work and negative work. Remember, what determines whether the work done is positive or negative was simply saying when the force and delta x, the movement of the object, the displacement, when they are in the same direction, we say cos 0 degrees, which means positive work is done. So you always look at the movement or the displacement and the force. Are they in the same direction? If it's like that, it is cos 0. And then we are saying for negative work done, we are saying the force and the movement or the displacement are in opposite direction. That makes an angle of 180. Hence, we are saying when it's like that, it will be cos 180 degrees. Then we say negative work is being done on the object. So you are able to see all that. And then we say no work is done if the force is perpendicular to the displacement of the object. So we're saying in this case, F delta x will be cos 90, and cos 90 is 0, so 0 work will be 0 joules of work will be done. Please always know that, and then we will know that you won't have a problem. The principle of conservation of energy, we talked about it. Energy cannot be created nor be destroyed, can be transferred from one form to another. The work energy theorem, which you are taking directly from the data sheet, work net equals to change in kinetic energy, like that, and then you are able to state as is written on the data sheet. Conservative and non-conservative force, we cannot do without the issue of definition of power, and then as well you must be able to know all these definitions as they are written in the exam guideline. I know you know some of them. It's just a question of adding on what you already know, because we want to ensure that all the definitions you get no 0, you are able to get your marks and you are able to move. Now, what is the strategy that you use for this question, which is our fifth question? We're saying the strategy for solving problems using the work energy theorem. We're saying you will have to draw a force diagram or a free body diagram. Please, you start there. You start there. Whatever you're doing Newton's second law, you will draw in the free body diagram before you apply your Newton's second law. You do the same here. You first draw a free body diagram or a force diagram, because work is done by the force. Remember, we are saying now the work done is the product of the force and the displacement in the direction of the force. So now you must be able to write the work net equals to change in kinetic energy. If the equation 2 cannot solve the problem, if this equation cannot solve the problem, you can write it as F net delta x cos theta equals to change in kinetic energy. And if that as well cannot solve the problem, you can say the work done by all the forces, the forces that are acting on the direction of the motion, then you are able to add all of them and say that is equals to change in kinetic energy. So you can use the same formula, but you can expand it differently, and it will help you to solve the problem. So I'm hoping that helps you. And we are saying you must be able to find the F net acting on the object, use a free body diagram to help you. And we are saying identify individual forces for which the F net is the sum, and find the angle theta between F net or each force acting on the object. So it's always important, the issue of the F, the force, and delta x, their relationship, whether they are in the same direction. I showed already that will be cos 0. When they're in opposite direction, that will be cos 180. And at 90 degrees, that will be cos 90. That will now be able to give us now no work is done. Now let's look at a question. Still saying the diagram below shows a crate of mass 50 kg being pulled up a slope from point A to point B at a constant velocity. See, constant velocity is even written in bold there. But sometimes you'll find that it's not in bold. You got to know that in constant velocity, there is information that you have there that you are collecting by saying that the slope makes an angle of 350 with the horizontal. 350 with the horizontal. I mean 35 degrees, 35 degrees angle, 35 degrees with the horizontal. The frictional force that the surface exerts on the crate is 250 newtons. So already you know that. The first question again, draw a level free body diagram. Then that's when you collect your marks of all the forces acting on the crate. So you can be able to see that crate that is being pulled. So you are having that dot that you have made. So you are having your tension there. You are having your friction, which is 250 newtons. Your frictional force. Don't forget, your normal force is always perpendicular to the surface, and your Fg towards the center of the earth. Right? I think you can see everything that I've drawn. And then after you've done that, don't be in a hurry to resolve the components. You will definitely do that when you do your calculations. And your calculations 5.2.1 was calculate the force F. That force, which is your tension, applied to pull the crate up the slope from point A to point B. The next one was calculate the work done by the force F upon reaching point B, when it reaches that point. And the last question was calculate the power. Remember, power due to the frictional force. Remember, constant velocity. I think it reminds you something about power. You say, oh, FV, under constant velocity, power is FV. So that information comes in handy because you're going to utilize it. And I hope all those skills, you will be able to utilize them. And you are able now to do your calculations. And then you are able as well to draw the free body diagram as I've done. And then you are able to calculate your work net there, which is change in kinetic energy. So you are adding all the forces that are acting on that particular object. And then there was a constant acceleration. And then hence we had the that equals to 0. And then we are saying now F equals to 531,053 newtons. And then remember the importance of that constant acceleration, because you can see that constant acceleration we're saying now Vf minus Vi equals to 0. Acceleration is 0. Now, F equals to 531,053 newtons. And then the work done by the motor there, we're saying is F delta x cos theta, which is that force of 531,053. And then you multiply that by cos 0 degrees Celsius. That gives you 428. The power, you can use your power now. You can be able to say, okay, the work done per unit time which in this case it was your 2 minutes, you multiply by 60 seconds, and then you're able to get your power of 35, and then you are able to get your 3 marks there. I hope that helps you as we move, and you know that under this question, the main thing, remember all the principles. Remember, if this question is about the work energy equals to change in kinetic energy or the work energy theorem, the question can be on mechanical energy. The main thing is that you know how to write the principle, which is now your EK plus EP equals to EK plus EP at another point. Then you are able to expand that and be able to do the calculation. So the main thing is understanding the real concept and be able to answer questions using this. Now, if you look at our sixth question, which is now Doppler effect. Here we are saying that you have marks to collect. You have marks to collect, and sure, remember we don't have many formulas that we are using under this one, except for your V equals to F lambda, your Doppler equation that is given in the data sheet. On the data sheet, you are able to do it now, and the application to say when do we do this Doppler effect. The next thing which is important is the issue of redshift. Remember, redshift, we are saying when we're increasing the wavelength. Hence, you see that we are saying the universe is expanding, because when the stars are moving away from the Earth, then you can see that we are increasing wavelength. When we increase the wavelength, then we're talking about redshift, and we only do redshift. We don't do blue shift in grade 12. Now, Doppler effect equation, important, copy it as it appears in the data sheet here, and then you are able to get your 1 mark for copying correctly, provided you substitute into that formula. And we're saying this equation is a combination of 4 scenarios. It can be a moving source approaching a stationary listener. Immediately when you say stationary listener, it's important for you to remember that FL stands for frequency of the listener. V stand for your velocity, your speed of sound, and then we are having now the speed of the listener. We are having now here the speed of sound, that V, and then we are having a Vs, which is your velocity of the source. So it's important to know which one is stationary, which one is moving, because the one that is stationary, definitely you are going to replace with a 0 there. But the first thing is to copy the formula as it appears. And if we are saying a moving source approaching a stationary listener, you know listener is L. So you will say V minus Vs. I want to explain this. That if it's approaching, it means that now we are supposed to divide. Remember, the listener is going to get more frequency of sound. The pitch will be high, which means that we got to have a lower denominator. Hence, for approaching, we are saying, okay, when the source is moving, then we'll subtract there at the denominator, and then we'll get a high frequency that we expect to get. We'll get a higher frequency than the one that the source is producing. So now, that's what you will do. But you first write like that. From there, you can substitute the 0. Then you are able to move, and then you can do all your substituting. Now, a moving source moving away. The only difference now for away, this is towards. So for towards, we're saying plus over minus. So you add at the top or at the numerator, you subtract at the denominator. But now, when it's moving away, it means now that you are the listener is going to get lower pitch, or the frequency will be low because it's going away, and then that would mean that it is V plus Vs. You see the difference? Toward away, you have a plus because you're going to have a lower frequency. You are dividing with a bigger number. And then moving listener approaching a stationary source. Now, when it's a listener moving, then you know that, okay, now you are saying, okay, the listener is approaching. The listener is approaching, so there's increase in the frequency. So in this case, you're going to have FL equals to V, because it's approaching, plus VL over V. That V, remember, is a stationary source. So that will be 0. So we're going to have a bigger number Hence, we are dividing a bigger number because we are adding here, subtracting with a smaller number because we are subtracting at the denominator. So for approaching, you know you will have that. Frequency of the listener will be high. Moving away, what I sometimes say deapproaching, you will know that the frequency of the listener is going to be low. How does that happen? We know that we have a small numerator and then over V there, like that. And you know that we are having a smaller numerator, still dividing the V, then we are going to have our frequency of the listener being low. So please, that's what you have to know. The next thing is to substitute the given information and you will be able to do questions. And I hope that will help you. Just to look at a question, an ambulance is moving away from a stationary listener with a constant velocity of 25 meters per second. The siren of the ambulance emits sound waves at a frequency of 550. So you already see that is the frequency of the source, 550 hertz, fs, 550 hertz. I mean, an ambulance is moving away from a stationary listener. Already, this is telling that the VL is 0, stationary, 0 meters per second at constant velocity. So it is the ambulance, the source is moving with a velocity of 25. The siren emits 550 hertz. The listener detects 512. So you can see that the listener is getting now less than what the source is producing. So you are able to see that this is away. This is moving away. So you are able to see that this is a movement in an away direction. Now the first always state Doppler effect. And then we are saying use the given information to calculate the speed of sound in air. As I've emphasized, you are going to copy the formula the way it appears on your data sheet, and you are able to substitute. You know your VL, you know your FS, you know your VS, you know your FS as well. So you are able now to just do the substitution, hence the importance of data collection, because here already you will be having 7 marks for doing that. And the question was, if the ambulance moves away from a stationary listener with a constant velocity which is greater than 25, how will each of the following change? So you're able to choose whether it will increase, decrease, or remain the same. The speed of sound in air. Remember speed of sound, that V, the V on the formula there, the V without an L and an S, we said it's a constant, that one. It does not change. It must be going to remain the same. The frequency of the sound waves emitted by the siren. Remember, the siren as well is producing the same frequency of sound. But what changes is what the listener detects. Because when it's towards, the listener will detect a higher one. When it's away, the listener will detect a lower one. So the frequency of the sound will remain the same, but the one that is detected by the listener depends. Because this one was moving away, then we expect it to decrease as well. So that's what we expecting. In terms of that, don't forget, you have defined Doppler effect as the change in frequency of the sound detected by listener, because the sound source and the listener have different velocities relative to the medium of propagation, and you are able to do the formula. I won't advise you to first do this, though 1 mark was given there. It will be just copied the way it appears in the data sheet. Then you can just do your substitutions. You can substitute even on that one. It's fine, but don't on the first time put the zeros and the plus and minus and all that. You will lose marks. So just ensure that you first copy it as is, so that you get that 1 mark of writing the formula, and then you substitute everything that we're given, and you are able to do your calculation, which is what we're having there. I hope that helps you. And then we're able to say the speed of sound in air will remain the same because it's a constant. We're able to say the frequency of sound. The source is always producing same sound with the same frequency. It's not changing, it remains the same. And then the one that is changing, we said, is the frequency of the sound that is detected by the listener, because that one will definitely be able to decrease. So I hope that helps you as we move to electrostatics. So we can see now all these questions were emphasizing the most important things that you must remember in order for you to go and collect those marks come the exam. Remember, in grade 10, you've done the quantization of charge. You've done the principle of conservation of a charge. Now in grade 11, you did Coulomb's law. you have done electric fields, and you've done electric field at a point. And we are saying this definition is very much important, that you know how to state Coulomb's law. You know how to define electric field. You know how to define electric field at a point. So that is very much important. There is your data sheet, important as well. When you want to remember your Coulomb's law, you'll be using that electrostatic force is directly proportional to the charges, to the product of the charges, and inversely proportional to the square of the distance between them. So it's important that you know that if I'm forgetting Coulomb's law, I'll go to that formula. I'll be able to see the product of the charges. I'll be able to see inversely proportional to the square of the distance between them. In electric fields, we are saying it's a region in space where a charge will experience a force. So we're saying a charge does not experience a force at all times. It can only experience a force if it's inside the electric field. Like when you're playing soccer, can only play soccer in the soccer field. So the same with electric field. A charge will experience a force if it's within the electric field. So it's important that we are defining electric field as a region in space where a charge will experience a force. And we are saying electric field at a point. Simply go to the data sheet by there, don't forget. And simply say, okay, it's a what? It's a force per unit positive charge. Force per unit positive charge. That is your electric field at a point. So that helps you as well. So you can see the importance of a data sheet because it's helping you to answer the questions that even sometimes maybe they were trying to be a problem. Now, when it comes to now you solving problems, that includes electrostatic forces. We are saying solve problems with changes in one dimension. You can see they are all in one dimension. So we can be given the magnitude of R, T, or S, and then we can be able to calculate the electrostatic force. Remember, you can calculate the electrostatic force between RT, you calculate the electrostatic force between TS. From there, because they are in one dimension, to get the net, you simply have to add them. But remember the vector nature of the force there, that you have to take into consideration the plus and the minus when you are adding them. So that's what you will do. But you can have a scenario where they are given in a right angle triangle like that. And then it gives you, now we talk about a right angle triangle, then you are able to see that now what is going to happen is that now you can calculate the force there and the force there. If you are given Z, if Z is not given, then definitely they will give you the F net, and then you can be able to determine what is Z and then be able to answer the question. So we are saying on this one, at a right angle triangle, you will calculate the force, you will know the force as well for this one, and you'll use the theorem of Pythagoras to get F net. In this case, we are saying the square of F net is squared is equals to the force, that one of xy squared, plus the force yz squared. So that is able to help you to answer. So the difference is to the F net here, which is now the vector sum of force of RT plus the electrostatic force of TS, I mean to say. So there you are simply doing the addition of your forces that we have calculated there. But here you are using the theorem of Pythagoras in order for you to answer that question. And then I'm hoping that you will definitely do that. The issue of electric field patterns, the electric field patterns, we are saying, remember, we can give you a single point charge to say you have a positive charge. Then you have to draw, don't forget, positive repulsion. Positive repulsion. Remember in your maths, you say positive times positive is positive. And like they repel. Hence, you can see the arrows are going outwards on the positive. And when it comes to the negative, is attraction. Then you know that how do you get a negative is when you have a positive and a negative. So the negative shows you that it is attraction. So the arrows are going inside. You can see that it's moving towards now. For negative, for positive point single charge is just like that away. For a negative one is towards. And when there are two of them, the positive and the negative, now they will be from positive still away. The arrows will be facing towards always the negative, and that's how you will be able to draw your electric field patterns. But when you're having a negative and a negative, definitely, but the arrows will be towards because those are all negative, but they won't be that joining together because now they are repelling one another because they are like charges. So positives as well, it will be like that going away. And I have emphasized the issue of electric field at a point. Said now electric field at a point is the electrostatic force, which is your force experience per unit positive charge placed at that point, as I indicated. That if you have forgotten, go to the data sheet. It will help you with these definitions, and you'll be able to answer the question. Now, with no wasting time, just to show you the type of questions that you are expecting, you are given A and B, which are placed two small spheres separated by a distance of 0.7. You can see that already. Sphere A carries a charge of 1.5 times 10 to the power minus 6. Sphere B carries a charge of minus 2. So you are given that sphere and that sphere A and B. And then now point P between A and B is 0.40 is given there from sphere A as shown in the diagram above. Now, what is important here is you must be able to define the term electric field at a point, which we said is the electrostatic force that is experienced per unit positive charge. And you must be able to calculate the net electric field at point P. So at point P, net electric field. Remember electric field, we are saying now E equals to KQ over R squared. For A, you do the same. For B, you say E equals to K. So you must indicate this is for A, this is for B, is KQ over R squared. From there, you are able to add them because you say net, you add them. Don't forget, it's a vector sum, so you must be able to indicate if there is negative and positive. And then a point charge of magnitude 3 times 10 to the power of minus 9 coulomb is now placed at P. Now they are giving you the value now at P point P, and then say calculate the magnitude of the electrostatic force experienced by this charge. So you are able as well to do that calculations, which in this case, the main thing that we are emphasizing is the issue of data collection. So you collect your data, and then you will be able to check, as I indicated, is KQ over R squared for A and KQ over R squared for B. And then you are able to add them. You get now your answer, which is 2.84 times 10 to the power of minus to the power of 5 Newton per kilo. Don't forget Q over Q. Remember we say E equals to the SI unit of your net there, which is Newton per kilo. And then we're coming from here, Newton for force and coulomb for that charge. And then you are able now to come and substitute, which is your E net, which is your E there, and then you are able as well to find the force, which is 8.52 times 10 to the power of minus 4. So hoping that you will do different types of questions as you remind yourselves. Yeah, it's important as we go towards the end of our lesson. It's important that we talk about electricity and the marks that you get here. Remember, when it comes to definitions, we're emphasizing Ohm's law. Ohm's law. Ohm's law is our first thing that when we're dealing with electricity, you will think of Ohm's law. Remember, we're saying the potential difference across the conductor is directly proportional to the current, provided that the temperature remains constant. Provided the temperature remains constant. Please know that and always remind yourself of that to say, okay, the potential difference across the conductor directly proportional to the current, provided the temperature of the resistor remains constant. Now, there is this formula that I like, the definition of a potential difference, which you said is energy transferred per coulomb. It helps you now when you have V equals to W over Q, when you have to define EMF. Remember, we can say define EMF. You're simply saying this is the maximum energy transferred per coulomb of a charge. So you are able to define EMF. For EMF, it's just the maximum energy transferred per coulomb of a charge. So please be able to remember those. They will help you. Remember, as you define your power, you're able to know is the rate at which work is done. So those things, they help you in terms of that, hence the importance, and we've been emphasizing the importance of data of the data sheet, because it always helps you when you have definitions that you have forgotten. You are able now to go and deal with that with no problem. You are able to go with it, and you are able to have your movement. Now, with no wasting of time, we're able now to move to the questions. Remember, we say reading, reading, reading. Always start by reading. To say the circuit diagram below shows a battery with an EMF. Already we talked about the EMF. To say this is the maximum energy transferred per unit, per charge of a kilo. Now, and we're saying internal resistance is given as 0.5 ohms connected to 3 resistors. You can see your resistors now. A light bulb, there's a light bulb as well, a switch as well, ammeter and connecting wires. The ammeter and connecting wires have negligible resistance. Now, switch S is initially closed. So we're talking about our switch there. You can see switch S there is initially closed. Look at 8.1. Define state, Ohm's law. So you are able to get that 2 marks. Please, the definitions, the stating, let's collect all those marks. Calculate the total resistance of the circuit. So remember, we're talking about the total resistance of the circuit, meaning that all the resistance, if we say of the circuit, we are not talking about total external resistance of the circuit. So this is important. External resistance, you are not including the internal. It's only external, and you can see that the external circuit is this one. So we are calculating the resistance there. But definitely you will first resolve your parallels there, so that you don't have issues with your parallel resistors. Remember, R1 and R2, or both of them with 10 there, they are in parallel. So you can just simply say, okay, you are able to say, okay, 1 over R parallel. Copy the formula from the data sheet, it will help you, which is 1 over R1 plus 1 over R2. From there, you can be able to utilize your product over sum. You can be able to say, okay, we have R1 times R2, that is for R parallel, with R1 over R1 times R2, product over sum. Then you do the sum of the two, which is 10 times 10. And I think if my math is doing well, 10 times 10 is 100. And then you divide by 10 plus 10, that gives you 20. And you are able to say 100 divided by 20. And then you are able to say R parallel there. These two, they will give us 500 over 20, which is 5 ohms. So you can see that we're having 5 ohms plus 10 ohm, which is 15 ohm, because they are in series. When they are in series, you add them. So you're saying, okay, these two now are in series, the light bulb and this parallel combination, they give us R for series to that series combination, which is 5 plus 10, which is 15. So we're having 15 and 15, which now they are in parallel. Remember, this 15 ohm is in parallel with the whole of this. So we have resolved the first parallel. This is a parallel within a parallel. So you must first resolve it and add it to this 10. Then you have this parallel and this parallel. Then you are able to say again, you can even say product over sum, which now will be 15 times 15, divide by 15 plus 15, which is 30, and then that will give you your 7.5. So you are able to do that, and you are able now to get your answer, and then that's what we are expecting from yourselves, to say you will do that, you will do your parallel, you get the 15 there as we have done, and then you will be able to get your 7.5. Or you can use other methods, but at the end of the day, they are all moving towards the same towards the same point where we are moving. Now, with no any waste of time, the other question was, I wanted to do that, reading on the ammeter A1. Reading on the ammeter A1. So now, remember, you know the maximum energy transferred per unit charge, per charge of a coulomb, which you said is the EMF, is 12 volts. So you are able to know that, okay, total volts is 12 volts. And do we know total resistance? Yes, we know 7.5 and 0.5 there. So if we add those two, they give you 8 ohms. So you're able to say, okay, if I have 12 over 8, which is I, current is I equals to V over R. I'm doing what I don't usually do because I will expect you to just copy the formula, which is now our R equals to V over I in the data sheet. Our total R, we said, is 7,5 for the external plus 0,5 for the internal. When you add them, you will get 8, which is equals to our V is 12, total V over I. So you can say 8I equals to 12. And then when you say 8, you can do your 8, your 12 divided by 8, 12 divided by 8, which gives us the total current of 1,5 amperes. So you're able to do your calculation of your current using that as well. So you're able to answer that. The power dissipated by resistor R3. What is of importance here, learners, is that remember we're having 1,5 current. Remember, our current moves from positive. We said it's conventional current. It moves from positive. The current is moving like that. As it moves, when it comes here, it finds now it has to split. That 1,5 amperes, which is the total current, it splits there. And when it splits there, it's splitting equal because it's 15 ohms and 15 ohms, equal resistor. They will share the current equal. So if you divide 1,5 by 2, which means 0,75 will come that side and 0,75 will come that side. Which means if this question is saying now calculate the power, you are able to say, okay, I can calculate power because I know the I know the R. I know the I know the R. I can calculate my power. Then you are easily able to do your calculation with no problem, and you are able to answer it with like that, which is 0,75, which we said the 1,5 will split, and then you multiply by the resistance there, which was 15. And if your calculator is working correctly, you are able to calculate power. So I'm hoping that you are getting ready and you are saying electricity. You can see that you can be able to collect marks as well as far as electricity is concerned. Now, the second the switch S is now open. Now, this switch S is now open. That one is now open. If the resistance of the light bulb remains constant, how will the brightness of the light bulb be affected? Choose from increases, decreases, or remain the same. And then the next question is saying, explain the answer to question 8.3.5. Now, what is important for you to understand is that when you open switch S, you are simply removing the 15 ohm resistor. Remember, we said the total external resistance was 7.5, if not mistaken. Now, immediately when you do that, it doubles, the resistance doubles. So it means now when you are increasing the resistance by removing a resistor that was connected in parallel. And then if you check that, it will mean that now you are going to increase the brightness. Why is that possible? We are saying that the total resistance of the circuit increases. Remember, it was 15 ohms in parallel with another 15 ohms. And now you have removed the 115 because now you no longer have a parallel combination, which means the total resistance has increased. We are agreeing, and the total current in the circuit decreases. Look, the relationship R equals to V over I. You know that if we are increasing now the resistance, we are decreasing now the current. They are inversely proportional. So we are saying that the total current is decreasing. And when that happens, we are saying the V internal and the V external faults. The V internal will decrease. V internal will decrease, or you can say the V external will increase. The V external will increase. Yes, remember V equals IR, the relationship there. As now we are increasing the resistance there, will increase the V. Then the power output as well will increase. Therefore, the brightness increases. So I hope that helps you when you deal with questions like that, to always know that if we are removing something that was in parallel, or a resistor that was in parallel combination, we are increasing the resistance. And as we increase the resistance, we are decreasing the current in accordance to our Ohm's law. Now, with no any waste of time, we move to our second last question, which is electrodynamics. Electrodynamics, we are saying now you are dealing with DC and AC generator, DC and AC motor. Remember, you must be able to know, how will I know that this is a generator? How will I know that this is a motor? Remember, for a generator, we are saying now this one is generating. So we are expecting output of power of our V, or our induced current, induced EMF. So we're expecting output. We're expecting that we don't have to have a source. But when it comes to motors, you are expecting a source, a battery, a DC source that is going to bring now the electricity, the source. There must be source of current. So this one is using electricity. This one is producing. A generator is generating electricity, but a motor is utilizing the electricity. Hence, the other one is output. The other one, we need input. We bring in. Now, how will I know whether it's DC or AC? Remember, for DC, we are saying now we're going to have a ring. That ring makes a D if you look at it correctly. We're going to have a ring that has brushes, and that ring, we call it a split ring, or we refer to it as a commutator. That ring shows you that this is DC. Whether it's a motor or a generator, as long as there is a split ring, one ring that has been split into two, we are referring to that as DC. Please, you will always find questions that talks to the components of a motor or a generator. And when we are having AC, you will be having now slip rings. So it's not one ring that has been split. These are slip, not slip for sleeping, but slip like that. So we refer to them as slip rings. So the structure tells us that a slip, when you see slip rings, is AC. Whether it's a motor or generator, you can have AC or DC motor, or AC or DC generator. How will I differentiate between them? I know that a DC will have a commutator or a split ring. An AC will have slip rings, and then you are able to differentiate amongst that. Please don't forget, those components are important. And then the issue of the principles. Remember, for the motor, we're talking about the motor effect. The motor effect as the principle which motors are operating. And then for our generator, we're talking about electromagnetic induction. So if we ask you what is the principle that generators use, you know it's electromagnetic induction. Electromagnetic induction. Please don't forget that. Be able to collect those marks. And remember, this is one of the questions where you are supposed to do very well and answer as many questions as possible. Now, you have the issue of RMS voltage versus RMS current. So this is important, because we are saying that here, if you are having an AC voltage or AC potential difference, that produces same amount of energy as its DC voltage or potential difference. That's what we call RMS voltage. So the main thing that you have to understand is that we are having an AC potential difference that produces the same amount of energy as its DC potential difference. So that's what we call RMS voltage. So it's just the main thing that you must remember is that when you talk about current, you will say AC current that produces same amount of energy as its DC current. When you talk about potential difference, you are saying AC potential difference that produces the same amount of energy as its DC potential difference. Please don't lose marks that says define RMS voltage or define root mean square current or root mean square potential difference or voltage. Please just put it as I put it, like that, and then remember there. I hope you are able to see and remember that. Now, the issue of using equations. You see the equations that you are given there in your data sheet as far as electrodynamics is concerned. They are all leading to the answer. And if you use them correctly, you will always get that. Now, I want to emphasize the issue of the graphs now. To say for AC graphs, because for AC graphs, you are going to be drawing your sine graphs, the sinusoidal graph like that. I'll just do 1 second. But it is important that if, for example, that was your V that you are moving with, it's important to say where is your graph starting. If it's starting at 0, it talks the position of your coil to say, okay, if my coil is vertical, it will start at 0 because the induced EMF is 0. Then it becomes maximum when it's horizontal. So you always have to have that in mind to say, okay, at 0 here, it means my coil is in this position. But at the maximum there, my coil is horizontal in that position. Please always check how the coil is indicated on the diagram, because it's going to determine where your graph will start. So if your graph is like that, is starting from horizontal position, you will start from maximum now, and then you are able to move like that, like that, like that. That's how you will do your drawing. So it's important. Remember, for AC, it's like that. We are changing direction every half cycle. But when it comes now to your DC, we're talking about now your frog jump now. Frog jump like that. That is your DC now. It's in one direction. It does not change direction. And then it's important to check where is your coil. Is it horizontal? If it's horizontal, it will start from maximum. If it is vertical, it will start from 0. That's what I want to emphasize as far as this is concerned. I've shown you there. If you look at this, we're having a DC motor. Say, how do you know this is a DC motor? I will always see I have a ring that has been split. So we call it a split ring, or we call it a commutator. So that tells me that this is a DC motor. How do you know, say, that this is a motor? We have a power source there. We have a power source. You can see there we have a cell there that is supplying. So you are able to look at the components, and then they tell you the type of structure that we are having. And then the generator, you can see that now what is happening there is still DC, because we are having one ring that has been split. So it's a DC generator. You can see that we are having our voltmeter there that shows that the voltage is being produced. So you see the importance of those things to see that, okay, as we bring the source, we are using a motor. As we produce the voltage, we are generating the power, the electricity there. So you are able to see the difference. And because it's DC, you can see how it is moving there in terms of the graph. Now, the issue of determining the rotation now, where we use the left-hand rule versus the right-hand rule to say, for motors, you are using the left-hand rule as indicated there. You will have seen you have the direction of the force, you have the magnetic field. Remember, our magnetic field is always from north to south. So as you put your hand, you must know that it's facing from north to south. So that's how we're moving from north to south. Then you can be able to determine the current, in which direction will the current move. And as you look on the other side, the generator, we're using the right-hand rule. Same principles. We are saying the first is the field, and then the second one, this one, is the current, and this one will indicate the motion. Then always from north to south. So if you're putting like that from north to south, you know that you will be able to determine the direction, and we won't have problems. Now, you have to know the comparison of your motors and generators. The main thing, a motor converts electrical energy to mechanical energy. So please don't forget, from electrical energy to mechanical energy is the motor. Remember, it's using electricity, so it must start with electricity. But a generator will be from a mechanical energy to electrical energy. And we are saying now, when we have our split rings, that is for our DC, we're saying we'll have a reverse current because of that. It's split rings as well. In this side, we'll have a DC output, and then the AC supply replaces the commutator, so you're able to deal with that. And we're saying the force strength, then, if you want to increase the force in the motor, you will use stronger magnets. You'll have more turns in the coil. You'll have a stronger current through the coil. Now, stronger magnets doesn't mean bigger magnets. It doesn't mean that because a magnet is bigger, then it's stronger. So you must have that in your mind. But if you want to increase the current that is induced, you will use stronger magnets, more turns in the coil, and faster rotation. Remember, we have the armature. because it's mechanical energy. It means we are mechanically rotating the coil in the magnetic field so that we can induce current in it. Hence, we are saying when we rotate the armature, we must rotate it faster. Then we'll have more current that is being induced. Now, look at an activity. Which one of the following actions will not cause the increase in the induced EMF in a coil if the coil is rotating in a uniform magnetic field? Now, let's look at this one to say which one. If we rotate the coil faster, will not. The keyword there, not. So this one, you know that it will increase the induced EMF or induced current. Increasing the strength of magnetic field. Okay, the strength of the magnet. Okay, you will increase that. Increasing the number of turns in the coil. Yes, it will have more. Replacing the coil with a coil of lower resistance. So you can see number D is just out. The last three are the three we talked about in the previous slide. Now, as well, the issue in the simplified AC generator side, the coil is rotated clockwise, and then we're able to do the questions as given, like that. I didn't show you the structure of the diagram. However, the last part, which is now you can be asked to write down the maximum output voltage of the generator. So where do you go for Vmax? So you're able to say Vmax is 340 there. A stove is connected to the generator above and delivers an average power of 1,600. So you are given P average as 1,600 watts. Calculate RMS voltage. Remember, you in your data sheet, you will have your formulas, your VRMS equals to Vmax over root 2 and all that. So you are able to always fall to that. So, okay, I have Vmax, which is 340. I divide by root 2, then I'm able to determine my VRMS. So please, learners, don't lose those marks, collect them, calculate the resistance of the stove, and then you are able now, you have the VRMS, the same thinking that you are having the R over the P average equals to VRMS times IRMS. As you go to your data sheet, you are able to get that, which now is you can use this formula of V squared over R, which is 240,42, which is what you got there, and then 1,006 was our power. You are able to determine the R. Always do data collection. It will help you as to which formula you're going to use. Now, this is the last section of what we are doing. Hoping that what we discussed here, you will continue to watch and continue to gain and practice as many questions and be able to understand. Remember, under photoelectric effect, you have three most important definitions that you cannot do without. The first one, you must be able to know what is photoelectric effect, which we are saying now, this is the removal or the ejections of electrons from the metal surface. So the main thing here, when you're dealing with photoelectric effect, is to have these two things in your mind, is to have energy of a photon and to have a metal. Remember, a metal has energy as well. We call it work function, which is the minimum energy required to eject electrons from a metal surface. So remember, as the energy of a photon, which is the energy from our light, we are saying that this energy, the metal has expectations to say, for you to remove electrons from my metal surface, this is the minimum amount of energy that I need, which we are referring to it as a work function. So work function is telling you that for you to remove the electrons from this metal surface, you need this amount of energy. So we'll always compare the energy that the light is bringing to the work function, which in this case is the minimum energy required by that metal for the electrons to be ejected. So it's very much important that you have those two. So we always compare the E and the W naught. Remember, energy of a photon, when it's less than work function, no ejection, no photoelectric effect. There will be no electrons that will be ejected from the metal surface. But now, when they are equal, when the energy of a photon is equal to the work function, remember now, what is going to happen is that Now we're going to have now removal, but we want to have EK because they are equal. There won't be movement. There will just be removal of an electron, but it won't be able to have EK. No traveling, just removal from the metal surface because there's no more energy that will take it somewhere. So what am I saying? I'm saying when we have more energy of a photon, than what the work function that is required, the other energy will be converted to kinetic energy. Hence, our formula is E equals to W naught or work function plus EK max. We penalize this one because remember, in the data sheet, the max is there. So we're emphasizing that that max must be part of your formula as you deal with this one. So always we'll have that. Remember, we're saying this is HF. But remember, everything on the left of this equation, it belongs to the light. It belongs to the electromagnetic radiation, which you have done from grade 10. Remember, you have done those colors. You said you have done the electromagnetic spectrum where you said Rami, Vuksh. You did like that. I'm reminding you now. You said, okay, we're having our radio waves, microwave, our infrared, our visible light, our ultraviolet, our X-ray, and our gamma ray. Remember, you were saying now gamma ray, it simply means this side, shorter wavelength. Shorter wavelength means higher frequency. So as you move that side, you are moving from you have shorter wavelength, which means higher frequency. So it's important to always know that the relationship C equals to F lambda, the relationship between frequency and wavelength, to say they are inversely proportional. If we are having higher wavelength, we are having lower frequency, always inversely proportional, which means the radio waves this side will have a higher, longer, the correct English is longer wavelength, and it will have a lower frequency. So you can see as we move that side, the wavelength decreases, the frequency increases. So you're able to see that, okay, as we come now, as the energy, because the energy is HF, is carrying the F, this F. So if I am bringing a gamma ray, obviously I'm bringing a very high frequency, which means now the ejection of electrons will be of highest proportion. So it's important to know which colors are we using. Remember, we have this as a visible spectrum now, where you are talking about your colors, your Roig beef, and then remember, yes, we are moving like that to say now as we move from red to orange to yellow to green in that order, you are able to see that. Hence, we are saying now the red shift. The red shift, we are saying now this one, it means the right way. If I'm to write it for your understanding, I will write it as Vicchio like that, so that you can see that as we move that side now, the wavelength increases far from, hence we're saying the universe is expanding. It means that now the stars are moving away from the earth. So you can see that the wavelength, the distance here is increasing. As we move there, the distance is increasing, which means the frequency is decreasing, meaning that this side will have a lower wavelength, and which means the frequency is high, hence the sky is blue. Now we are saying, what am I saying to you now? I'm saying when we say redshift, we are simply saying that longer wavelength, we are moving towards the redshift. That's where you will find our galaxies that are stars, our stars that are more away from the Earth. So it's longer wavelength for the red color there, which is your redshift that I talked about. So it's important to always look at the frequency because it's telling us whether we will be able to eject electrons or not. So I hope I've talked to that. Now there is this issue of you have to be able to expand this one. You can say HF0 plus half mv squared max. Now you are able to see that this frequency we can be given wavelength. Don't forget, you can say hc over lambda. And this energy that is on the left of this equation, my learners, is to say this is the energy of a photon, which is a packet of energy. it's important to know that this is a packet of energy. One packet of energy removes one electron, meaning that if we have one HF, it will remove one electron. When you increase the intensity, you are increasing the packets, the number of packets of this energy. So you will be able to eject more electrons. So you must got to understand that when you're increasing the intensity, sometimes we'll say the brightness, but what we are doing, we're increasing the number of photons. Remember, these photons, they always carry the same amount of energy. So I want us to have that on what we are doing. And then with no wasting of time, we move the issue of definitions. You will know these three, seeing them. We are saying photoelectric effect is the process whereby electrons are ejected from a metal surface when light of suitable frequency is incident on that surface. We are saying threshold frequency is the minimum frequency of the light needed to emit electrons from a certain metal surface. So it goes with work function. Remember, where do we get threshold frequency? We get it here. To say, okay, if you take Planck's constant, you multiply it by threshold frequency, you'll get the work function. What is the work function? It's the minimum energy that an electron in the metal needs to be emitted from the metal surface. Now, I always find this important for you to be able to see that when light is shown into a metal surface, in relevance, remember, when you're doing your sorry for that. When you're doing your anodes and cathode electrolytic cells, you had for electrolytic cell you had a positive cathode. That's the same thing. We say positive is cathode. So you are able to see that this one where we are having this, we are going to have a positive cathode. You are having a positive cathode. So it means light is shown, and to remember a positive anode. It means that electrons are there where the anode is. Hence, we are showing the positive anode. We are showing light onto our cathode where our electrons are. Again, we said panic. I'll just do like that. Then you are able to see that as we show the light, electrons now they gain that energy, they become excited, and because energy, there's more energy that is being supplied, then they are ejected, and we call this photoelectric effect. So if you see each of these, we are referring to it as a photon, a packet of energy. So each photon will eject an electron. So if we increase intensity, we're increasing the number of these packets of energy, hence more electrons will be ejected from the metal surface. I hope that helped you and you were able to get that and we are able to move. Now we are saying electron can only absorb one photon, so the rule there is one photon, one electron. So when you increase the intensity, we're increasing the number of photons, so that you have that in the understanding. And I indicated these three scenarios to say E equals to, if E is less than the work function, no electrons will be ejected. And if E is equals to W0, photon are absorbed and photoelectron ejected, with EK equals to 0. So there will just be an electron will be removed, but it won't have EK because it's equal. But when it's greater, the rest of energy will be converted to the kinetic energy. So here is a question that says define work function. It says the minimum energy needed to eject an electron from a metal surface. Please don't forget those three definitions. Define photoelectric effect. That is the ejection of an electron from metal surface when light of suitable frequency is incident on that surface. And then you're able to calculate the frequency of the incident radiation. Now, what is important here is for you to have data collection to say, I'm given the work function of potassium, and then the maximum kinetic energy of the electron ejected is 4, so I have the work function, I have the maximum, and you are asked to calculate the frequency. So you can see that E equals to work function plus EK max. Then you are able to see that the work function is given plus the EK is given as well. So you're given W0 plus EK max. You add these two. On the left hand side, you are having E equal, which is HF. The question say calculate the F. So you just have to substitute the frequency, and you are able to get your answer. And then, as I explained, you will do that, and then you are able to calculate your frequency there. And on the question that says calculate the wavelength, you are able to calculate your wavelength as given like that. And then the question of intensity is important. I want to emphasize it to say the intensity of the incident radiation on the metal is increased. So when you increase the intensity, you are increasing the number of photons, and then per unit time. So you are able to say now, while maintaining a constant frequency, state and explain what effect this change has on the following. Remember, when you increase now the intensity, you are not going to change the energy, the kinetic energy. What you're going to change is the number of photons, which means the current, the number of photons that will be ejected will increase, but all of them will have the same kinetic energy. So you got to understand that as we increase the intensity, yes, we're going to have more electrons that will be ejected. But all of them, because remember, all these photons, they carry the same amount of energy. So our EK will remain the same. It won't be affected by increasing intensity. But what will be affected, or what will increase, will be the number of photoelectrons that will be emitted, because you have more packets of energy, and we said one packet will remove one electron. I hope that helps you as we come to the end of our lesson. I hope you got a lot. You will write all the 10 questions. You will answer all the questions. You will ensure that all the multiple choice questions are answered, all the definitions, you respond to them. If you have difficulty, you will go to the data sheet. All the calculations that says calculate, you will go to the data sheet and identify the correct formula and substitute into that formula. And you'll write the final answer with SI unit and direction. And then I finish with these ways to say anyone who has never made a mistake has never tried anything new. So don't be afraid when you are writing your exams. Stand there, answer all the questions, enjoy yourself till we meet again. See you next time. Goodbye.